O is constant. So thus, we are going to use this equation, and we've got the sum of the forces in which we've got weight, Stokes force, and Archimedes force, which is 0. And let us then transform this into normal equation, taking in mind the direction of the forces, not to be vector ones, so weight. However, we've got negative Stokes force because it is directed in the opposite direction, and Archimedes force in the opposite direction. So thus weight is the sum of Stokes force and Archimedes force. So we'll start from here. And I'll clear above. And weight of the erythrocyte. Weight of the erythrocyte is mass of erythrocyte. I'm going to write subscript TR, acceleration of gravity. Then Stokes force is 6 pi erythrocyte radius, ER here, viscosity of the fluid, travel velocity, plus mass of the plasma times acceleration of gravity, which is Archimedes force. So that's what is this erythrocyte sedimentation rate? This one, velocity of settling. This is velocity with which erythrocytes move in the response of the force of gravity. So thus, let us from here express it. So we've got 6 pi r erythrocyte eta v is left-hand side minus this second term of the right-hand side. So G. So from here, let us find that settling velocity, our erythrocyte sedimentation rate. Okay, I'll continue to write with hope that this will change quickly. Okay, so that's I have expressed, but in this case we can continue with the modification. Mass of erythrocyte, let us write here, mass of erythrocyte, it is erythrocyte density times the volume. If we consider volume spherical, then according to the formula for the volume of the sphere, we've got 4/3 pi erythrocytes radius power 3. This is volume. This part, of course, this one is the volume. Okay, so thus let me substitute in the equation. So thus we've got 4/3. Still not ready. Mass of the plasma displaced. Pay attention. It is density of the plasma times the volume displaced, which is the same as the volume of erythrocyte, which means density of the plasma and the same term. 4/3 pi erythrocyte radius power 3. So that's the difference which is in the formula. Mass of erythrocyte minus, just a moment to clear. Mass of erythrocyte minus mass of plasma is, so this minus this, we've got density of erythrocyte minus density of the plasma, and then 4/3 pi radius, erythrocyte radius power 3. And this we have to substitute in the formula, and then we get the final expression for the erythrocyte sedimentation rate. Let me write it now. V equals, so we've got 4/3, this one. Then we've got, let me write initially this, pi r erythrocytes power 3. Then we've got this is 3 here, not well visible. Then we've got the difference between densities of erythrocyte and plasma. Then in the denominator, we've got times, let me write here, times 4/6 pi radius of erythrocytes and viscosity. So thus we can simplify 2, 3. Then pi cancels pi in the denominator. Third power with this becomes second power 2. So that's what is left. 2 divided by 3 times 3, 9. We've got erythrocytes radius second power. Since we cancel it, just to sorry, difficult to write here. This again, sorry, can't write well. So just 2 divided by 9. Erythrocytes radius power 2. Then the difference, can you see? Not well. Then the difference between erythrocyte density minus plasma density. We've got acceleration of gravity divided by pi cancelled just by dynamic viscosity coefficient. So thus you can see what are the factors. So not good written, but this one is erythrocytes power 2. ER is subscript of R, second power. Difference between the two densities of plasma and erythrocyte, dynamic viscosity coefficient. So thus these are the factors determining this non-specific but frequently used diagnostic indicator of inflammatory condition. So that's I would like I have by and by prepared test, but what is the reason for not? Just a moment to see once again. Okay, so, okay. So, what I need what is the unit of pressure? This I noticed. So, pressure is measured in pascals, which is defined as, so let us write this. Pressure is measured in pascals. 1 pascal is, since pressure is force per area, 1 pascal is 1 Newton per meter squared, equals 1 Newton per meter squared. So this I omitted. So thus, let us now revise the most important things of today's lesson. So, firstly, what is pressure? How to define pressure? Globally, pressure is force per unit area. Force per unit area. Pressure is scalar quantity. Pressure is involved under the basic principles, which is called Pascal's principle. Pascal's principle says what? That any change in pressure is equal and diminished to all to every part in a fluid. So, Pascal's principle is used to explain what? Different applications. Medical, conventional diffuses also. Explaining what way to use it to diagnose tumors in cerebrospinal fluid. To explain why, if as a result of blow on the eye, we may reduce, or their injury may occur, even if no visible damage is observed on the eye surface. Also, in case of water collection in pleural and pericardial cavities. Also, in case of fetal deformity on the stomach. So all those applications we discussed. How we discussed how to calculate pressure within fluid using a simple equation, which is called that pressure within fluid. At some point in a fluid is called inotway. Absolute pressure. Also it is called liquid. It is equal to what? To the atmospheric pressure plus hydrostatic pressure. What is hydrostatic pressure? Hydrostatic pressure is what? Pressure due to a force. What force produces hydrostatic pressure? regressive weight. So the pressure hydrostatic is due to the weight of liquid of liquid column. So in fluid statics, also we mentioned Archimedes force and phenomena buoyancy. What is buoyancy? How to explain this buoyancy? What is it? It is a phenomenon which explains why the weight of an object reduces as a result of submerging it within some fluid. So what makes the weight of the object decrease? What makes it to decrease if it is submerged in a fluid? What is the reason? Is anybody who can tell? Archimedes force is the reason. Why? Why Archimedes force is the reason? Because it is directed upwards. It tends to move the object upward. This does not happen always. Why? Because the location of the object within the fluid depends not only on the Archimedes force, but also on the weight of what? Of the object, which is the weight of the fluid displaced as well. So Archimedes force can be defined as what? In what way can we define Archimedes force? Archimedes force is the upward force which is equal to the weight of the fluid displaced. To the weight of the fluid displaced. Since when being submerged, some fluid is displaced by the object, and the weight of that displaced fluid determines the Archimedes force. So what medical application of Archimedes force we studied? In case of urinometer, which measures what quantity? Specific gravity or relative density. And this is used in case of diagnosing some disturbances in relation to the changes in the content of plasma, in the protein concentration. So, what is the most important law in fluid dynamics which we studied today? We studied Clausius law. Clausius law is about what? It's about volume flow rate. And globally, how to state it? Volume flow rate is proportional to the pressure gradient. But also we can say shortly it is directly proportional to the pressure drop. We decided to use this term drop showing what? The difference. Delta P pressure drop, how much pressure decreases, and inversely proportional to the so-called resistance to flow. And another equation important in fluid dynamics is called continuity equation. What does it show, continuity equation? It says that the product between cross-sectional area and travel velocity or flow velocity is constant. Which means that if the cross-sectional area decreases, velocity increases and vice versa. So important application to explain why atherosclerosis is a life-threatening condition. So Stokes force, it shows us what is this Stokes force? It is the force of friction. It without motion. It is related to the travel velocity. This formula we use today for us to derive what equation. For electrocyte segmentation rate. Since travel velocity is the derivative in the Stokes force. So next time we will focus on circulation and specifically pressure and the circulation system, the functioning of the heart, being a pump mechanical. That's why please study the base material, since essential part of it we will use for the next time to explain the topic. So once again, let me tell you, eventually I'll choose some groups for giving tests, and I will check lecture notebook of those tests, those students as well. So just to see what students write in the lecture. That's all for today. Nice day.